Alright, so we now move on to trig equations, and the first trig equations we're going to start solving are the ones that are going to look like sine theta is equal to y, or cos theta is equal to y, or tan theta is equal to y. Now these are going to be called the linear method. Now the reason we call them the linear method is because there's a power of 1. And we're going to see that these can get a little bit more complicated as we go along, but for the moment, if you're able to translate your equation into something that looks like one of these three, then you're able to solve it using the linear method. So, we want to solve the equation sine theta is equal to negative half. So far what we've done is we've actually solved for the answer, the exact value of sine of a specific angle. In this case, what we want to do is we need to work backwards now. We need to figure out, okay, what is the angle of rotation that will give me a value of sine being negative half? So, when is sine half? Well, that's the first thing we need to look at. So where on the unit circle is the sine half? And we have two values where it could be half. And the reason for that is because you have the negative. So in other words, the half is represented in all four quadrants. So sine of half is going to happen at 5 pi over 6, or at pi over 6, 7 pi over 6, and 11 pi over 6. But only at these two angles will you have a negative value. So how would you go about solving this type of an equation? Well, you ask yourself, when is the value of sine a half? Alright, and then we would say our reference angle would need to be either 30 degrees or something over 6. Alright, then what? Well, when is your sine negative? Quadrants 3 and 4, because the y value is negative in quadrants 3 and 4. And the only reference angles in quadrants 3 and 4 would be 7 pi over 6, or 210, and 11 pi over 6, which would be 330. So those would be the two answers of theta. So in other words, where on the unit circle is the sine value negative half? When theta is 7 pi over 6 or 11 pi over 6. So we have two possible answers. Now, if I were looking for all the solutions to my equation, so sine theta is equal to negative half, well then we would need to add this 2 pi n. The simple reason is that if I were to continue revolving around my circle, my angle of rotation would keep on constantly increasing. But when would I get negative half again for my sine value? Well, when I did another whole turn to get me at 7 pi over 6 as a principal angle. So to each of my answers, if I would like all the solutions, I need to add 2 pi n. And in this case, the n represents any integer. It can be negative, it could be positive, it could be 0. 0 would just tell you that you're not doing an extra turn around your circle. You're just doing one complete turn, and that would be all. So, all our solutions would be 7 pi over 6 plus 2 pi n, or 11 pi over 6 plus 2 pi n. So let's do the next one. Find all solutions to 2 cos theta plus the root of 3. And all of this is equal to 0. So my first step would be to say, okay, well, can I isolate cos theta is equal to something? Am I able to get it into the linear method? And the answer is yes. Cosine of theta is equal to negative root 3 over 2. So when is cosine of theta equal to negative root 3 over 2? So again, ask yourself, when is the cosine of theta root 3 over 2? What would be that reference? That reference angle would have to be at 30 degrees. However, when is the cosine negative? In quadrants 2 and 3. So that means my answer for this one would be 5 pi over 6 and 7 pi over 6. But because it's asking me for all the solutions, I need to add my 2 pi n to both of those answers. So theta would be either 5 pi over 6 plus 2 pi n, or 7 pi over 6 plus 2 pi n, where n represents any integer that would tell you the amount of times you revolve around your circle. So let's try the next one. We get 2 sine theta plus 4 is equal to 0. If I were to isolate for my sine of theta, I get sine theta is equal to negative 2. And now you ask yourself, okay, well, when is your sine going to be equal to negative 2? And the answer to this would be never. Now, why would it never be equal to negative 2? Well, let's go back to what we're actually looking for. We're in a unit circle, which means the maximum unit that we could be dealing with is 1 or negative 1. Now, if you wanted, you could also try taking the arc sine, so sine with that little negative 1 of negative 2, and you would see that you would get a math error. The reason you get a math error is because you have an empty solution set. So you are rejecting this. You are saying it's impossible. There is no angle theta where you would take the sine of this angle that would give you negative 2. So in this case, we get no solution. There's no solution set. It's an empty solution set, in other words. Next one, let's solve tan squared theta is equal to 1 over 3. But in this case, they're giving us the interval from 0 to 2 pi, excluding 2 pi. So, again, I always ask myself, can I put it into the proper format? I need tan of theta is equal to something. Well, how do we usually get rid of a square? We take the square root. So, what we are going to do is we're going to take the square root on both sides. And by taking the square roots on both sides, I now get the positive and negative of root 1 over 3. So that means that my tan of theta would be equal to the positive and negative 1 over the root of 3. Now ask yourself again, when is your tan of theta equal to 1 over the root of 3? Now, if you wanted to and you say, okay, well, I don't know what 1 over the root of 3 is, we can always ask ourselves, what's the rationalized value? That's the value that you have in your remarkable angles chart. So that would be root 3 over 3. And we know that on the unit circle, this would end up being at 30 degrees. So again, we have another reference angle of 30 degrees. Now, because it's not written on my chart, does that mean I start to panic? No. All I need to do is take the sine value and divide it by the cosine value. So half divided by the root of 3 over 2, and I get 1 over the root of 3. Just because tan of theta is equal to sine theta over cosine theta. Or if you memorize your tan remarkable angles, that's fine also. That would be acceptable. And in this case, you would realize that you get a value of 1 over the root of 3 in quadrant 1, 2, 3, and 4. And why am I accepting all of these 4 answers? Well, because it's a positive and negative. So in my first quadrant, I get positive. In my second quadrant, I get negative. Third quadrant, I get positive. Fourth quadrant, I would get negative. So in other words, my answer to this would be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And because they do not ask me for all the solutions, they just ask me on this interval from 0 to 2 pi, I just have 4 possible answers. And that would be it.